Hello students, welcome back to the 7th video of this playlist. So in this video we will be solving question number 7 from June 2023 P4 paper. So let's see what's the question number 7 is about. So basically question number 6, it's from proof by contradiction, that has been discussed in the very first chapter, that is chapter number 1 of your P4 book. So in order to be able to solve this question, you should have definitely gone through the chapter number 1, through the concepts of chapter number 1 of your P4 book. So let's get started with question number 7, proof by contradiction. The name itself says contradiction. That means something that is opposite, right? Contradiction. Proof by contradiction, that means we need to prove coming from the opposite. So basically the main theme of proof by contradiction is that we will assume the opposite thing to be true, and considering the opposite thing as true, we will keep doing the algebraic workings, and as we do the workings we will see that we are approaching towards something that is impossible to happen. Okay, so impossible to happen means mathematically or with related to calculations, like with algebraic manipulation or anything. We will see that the workings, it is approaching towards something that is not possible to happen according to the concepts of maths. So if we can figure out like something that is impossible to happen, it is occurring with our workings, this will be the what? Contradiction. Why this will be the contradiction? Because we are doing the workings assuming the opposite thing, right? So since we consider the opposite thing is the true, and using the opposite thing we are doing the workings, and we have seen something what? Wrong, like something that is happening not perfectly, right? So that means our assumption is basically what? False. Our assumption was not true. This is the contradiction. So in this case, question number 7, they said use proof by contradiction to prove that what? 𝗓𝗏 is an irrational number, right? Okay, there is a very important hint given there. You may assume that if k is an integer, okay, then k squared is a multiple of 7, then k is a multiple of 7. We can use this concept here. Okay, so let's start. Proof by contradiction, that is we have to come from the opposite. Fine. So what would be the opposite here? Assume that what we can assume that √7 is a what? Rational number. Fine, it's a rational number. Okay, so if √7 is a rational number, then algebraically, using the concepts from algebra, what we can consider? √7 is a rational number. We know that rational numbers can be represented as what? Fraction, right? So √7 equals to what we can write? P over Q. This is the fraction, and you need to give some hints there that P and Q are in its simplest form. Okay, P and Q are mutually coprime. Okay, are coprime numbers where P and Q are what? Coprime numbers co-prime numbers and the fraction is in its what? In its simplest form. Okay, this is the assumption. Now let me explain what I have written in the bracket. P and Q are co-prime numbers. What does it mean, co-prime numbers? Co-prime numbers means both P and Q are prime numbers. So if both P and Q are prime numbers, then we know that prime numbers have factors itself and 1, right? Prime numbers has factors itself and 1 only. So since P and Q are co-prime numbers, that means P over Q, it is in its simplest form, then you cannot simplify it any further. Okay, and you should have known this concept that rational numbers can be represented as fraction, like 2. 2 can be written as what? 2 is a rational number, so we can write 2 as 4 over 2. We can write 16 over 8. We can write at 30 over 15. Like 2 can be represented as a fraction. Like as that, all rational numbers can be represented as fraction. Okay. So what we can do? Do the cross multiply. So P equals to square root of 7Q. Okay. Now square both sides. So what you will get? P square equals to 7Q squared. So then what we can say? Look, we got P square equals to 7Q square. So what we can say? So P square is a multiple of 7, right? Is a multiple of 7. Like the things I'm doing right now are basically algebraic workings. I'm considering the opposite thing as true. Okay, the opposite thing as true. I'm doing the algebraic workings, and we will see whether it goes towards something that is impossible or not. Okay, so P square is a multiple of what? 7. So they said what? If K square is a multiple of 7, then K is a multiple of what? 7. So what we can say? Therefore, since P square is a multiple of 7, so we can say P is a multiple of what? 7. Simple, isn't it? Multiple of what? 7, as per their given hint. Okay. So what we can write? So P equals to what? 7K. We can write P equals to what? 7K. So if P equals to 7K, now what we can write here? Look, P equals to 7K. We know that P equals to what? Square root of 7Q, right? We know that P equals to 7K. Now if you square both sides, what you will get? P square equals to what? 49 what? K squared, right? Now we know that P square equals to what? 7Q squared, right? I squared both sides, so I got P square equals to 49Q squared. Now we know that P square equals to what? 7Q squared. So you can just substitute in place of P square what? 7Q squared. So 7Q squared equals to what? 49K squared. Okay. So if you make Q squared the subject, you will get 7K squared. So 7 times K squared. That means what? Q square is also a multiple of what? Is also a multiple of what? 7. So hence what we can say? Hence Q is a multiple of 7. Now there's a problem. Now look, we are approaching towards something that is what? Impossible to happen. That is what? Impossible to happen. How? How this is impossible to happen? Look, according to our assumption, it is impossible to happen. Why? Look, in our assumption we said what? Where P and Q are co-prime numbers. That means P and Q are co-prime numbers. That means they won't have any common factors, right? But look, if P, we got that after algebraic workings, we could see that P is a multiple of 7. At the same time, Q is also a multiple of what? 7. That means both P and Q has what? Both P and Q has what? 7 as a common factor. So both P and Q has common factor what? Common factor 7. And P and Q are not what? Are not coprime. Not coprime. Like the thing, after doing algebraic workings, we can see that we are actually getting everything opposite to our assumption, isn't it? P and Q are what? Not coprime numbers. Coprime numbers. Okay. P and Q are not coprime numbers, and what we can say, and the fraction is not in its simplest form, right? Since P and Q are not what? Not coprime numbers. Okay, so this is totally this approach is totally contradicting our assumption. Hence it contradicts our assumption. Okay, hence it contradicts our assumption. Therefore, what we can say, since it is contradicting our assumption, so our assumption was false. That means the opposite thing would be the true. Therefore, it is proven that square root of 7 is what? Square root of 7 is an irrational number. Our assumption was rational number, but it has contradictions. Therefore, the opposite thing, that means square root of 7 is an irrational number. And that's the proof by contradiction. That is question number 7 from June 2023 P4 paper.